Okay, now that we know about our product rule and quotient rule, we can talk about just multiplying and dividing radicals in general. So this is just using our distributive property, except the numbers might be radicals, but it's the same process. You just distribute over the addition or multiplication sign, and when you multiply radicals with non-radicals, whatever's outside the radical just multiplies together and stays outside. Whatever's inside the radical multiplies together and stays inside. So this would be 5 times the square root of 11. Okay, the 5's not under a radical, don't put it under a radical. The 11 is under a radical, leave it under a radical. And then minus, and this time the 11 and the 2 are both under radicals. So multiply them together and leave them under the radical. Now, I would need to see if these radicals simplify, but of course 11's a prime number, so it doesn't have any factors. And 22 is only 11 times 2, so it doesn't have any factors that are perfect squares. So that's it for it. Same thing over here. This would be 7 times the square root of 54. Okay, minus 7 times the square root of 24. Whatever's outside stays outside. Whatever's inside stays inside. Now these will simplify. So I got to simplify these things. So 54 I can rewrite as 9 times 6. So this is 3 times 3 and 3 times 2, right? So I can change this to 7 square roots of 3 cubed times 2. This one over here, I can make 4 times 6, which is 2 times 2 times 2 times 3. So mine is 7 square roots of 2 cubed times 3. Okay, anytime you get an exponent that's bigger than your index, it'll simplify. 2 goes into 3 one time. So I can bring out 1 3. But 1 stays underneath, right? And then times 2, because the exponent's already smaller than 2. Over here, 2 goes into 3 one time, so I can bring out 1 2. But 1 stays underneath. So I've got 21 square roots of 6 minus 14 square roots of 6. Hey, if those radicals wind up being identical, we can combine them. 21 of them minus 14 of them is 7 square roots of 6. Okay, so really everything involved in this process is stuff we already know. We're just putting it all together. Okay, same thing here. Stuff I already know. I know how to multiply binomials, and I know how to multiply radicals. I'm just going to put the radicals together with the binomials. All right, so this would be 2 plus 2 square roots of 5 plus 1 square roots of 3 minus square root of 15. Okay, none of these will simplify. That's only 5 times 3. None of them are alike, so I can't do anything further with that. Okay, let's do it again. 16 minus 4 square roots of 5 plus 4 square roots of 5 minus square root of 25. Well, here's minus 4 square roots of 5 plus 4 square roots of 5. So that's 16 minus square root of 25 is 5. 16 minus 5 is 11. Okay, so on this one, I've either got to remember that this is square root of 13 minus 2 times square root of 13 minus 2 and do my distribution there. Or I can do the shortcut because it's a perfect square trinomial. So the shortcut, so you can either distribute like up there, or the shortcut is you square the first one. So if you square square root, it goes away. You multiply the two terms together, so you'd have negative 2 times that, and double it. And then square the last one. Negative 2 times negative 2 is positive 4. Now these terms you can combine. 13 plus 4, 17 minus 4 square roots of 13. So however you want to do that. One thing I want us to notice while we have all these on the page, look at this one. This one still has radicals. This still has radicals. This one wound up getting rid of the radicals. That's something we're going to use here in just a minute. And then whenever that happens, it's because you had these things, the difference of squares. Remember, we could have also used a shortcut to multiply this out. Square the first one. Square the first one. It's always a minus. And square the second one. If you square square root, it goes away. Okay? So these are special products. And in particular, I want to keep this in mind and what happens. Okay, rationalizing the denominator. We talked about already, when you're simplifying these rational numbers, you cannot have a fraction left under a radical sign, and you cannot have a radical sign in a denominator. Okay, so we're going to rationalize the denominator. Every one we've done so far, the denominator had a perfect square, and it went away. But what if, the radical sign when we took the square root, but what if my denominator has a radical that doesn't have a perfect square in it? We're going to do something called rationalizing the denominator. Make it a rational number instead of an irrational number. And it's based on the idea, think about this, I can take any fraction, and as long as I do the exact same thing to the numerator and the denominator, right, it makes an equivalent fraction. I can multiply it by anything I want, as long as I do the same thing to the top and the bottom. I get an equivalent fraction. 1/2 and 3/6, same thing. 1/2 and 5/10, same thing. So I can multiply this fraction by anything I want. I want to multiply it by something that will get rid of that radical. That will be a square root of 11, right? Because that'd be square root of 121, which is just 11. Once I figure out what I'm doing to the bottom, just multiply the top by the same thing. So on top, you have 5 times square root of 11. On the bottom, you have square root. I'm going to do it this way just for future reference. That'll help us. You could write square root of 121 if you want, and then realize, oh, that's 11. Or I'm going to say 11 times 11 is 11 squared so that I know that'll simplify. So 5 square roots of 11 over 11. I've rationalized the denominator. It's still equal to this, just like 5/10 is still equal to 1/2. It just looks different. Okay, so here I need to multiply by, what do you think? Yep, square root of 5. Just the identical thing, because when you multiply by itself, it's squaring it. And when you square something, right, you get rid of that square root. When you figure out what it is to the denominator, do it to the numerator. So on top, you have 5 times square root of 30. And on bottom, you have square root of 25. I'm going to write it like this just so we can see easily. Now I got to think about simplifying this, but that's 6 times 5, or 2 times 3 times 5, so I know it doesn't simplify. But I got to check it. Don't forget, I got to check it. So on the bottom, I just have a 5. Now don't forget, anything that's the same in numerator and denominator can divide out. Okay, rationalizing the denominator. We started out with fractions with rational numbers in the denominator and wound up with ones without. This has a 1 for a denominator, right? Without rational numbers in the denominator. Okay. Now, I want to pay attention always to my radicals. Let's simplify this thing first, right? This is 9 times 2. So it's 3 times 3 times 2. So really I can write this as -8 over the square root of 3 squared times 2. Okay? Which is -8 over the square root of 3 squared times the square root of 2. Now this goes away, -8 over 3 square roots of 2. Now, I didn't completely get rid of the radical, but the number I'm going to multiply top and bottom by is much smaller. And because I don't want to multiply this by square root of 18 and then have an 18 here, I got to simplify, and then I'd have an 18 times 18 and have to simplify that and reduce the fraction. It's just easier to make your numbers smaller before you have to make them bigger. So here's my problem. That means all I got to do is multiply by square root of 2. Whatever I do to the bottom, do the same thing to the top. Okay, so -8 square root of 2 over 3 times square root of 4, right, or 2 squared. So -8 square root of 2 over 6, and then this will reduce. So finally we have -4 square roots of 2 over 3. Okay. I can't have fractions under radicals either, but we've got our property that says, hey, I can just simplify this by separating them. Now, my problem is I can't have this in the denominator. Okay, but I want to try to simplify my radicals first. Okay, and I notice, hey, I can simplify this one and this one because 8 is 2 cubed. So this is 4 times 2, right? Or 2 cubed. 45 is 9 times 5. So it's 3 squared times 5. So writing them out however much work you need to do to get those in their factored forms. And then once they are, 2 goes into 3 one time, so I can bring 1, 2 out, but 1 stays in. Okay, 2 goes into 2 one time, so I can bring 1, 3 out with nothing in but the 5. Okay, now look how much smaller all my numbers are, and I can rationalize that denominator with smaller numbers. Okay, so on the top we have -2 times square root of 10, which doesn't simplify any further. And on the bottom we have 3 times, can I just do 5 now? 3 times 5, right? This is square root of 25, or square root of 5 squared, or 5. Okay, so finally, -2 square root of 10 over 15. Now, don't forget, these things won't simplify. One's under a radical and one's not. That's not 10, right? It's like 3 point dot 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 never ending. It's not 10. Okay. The dreaded plus and minus sign. Right? So, if we're trying to rationalize a denominator that has a plus or minus sign in it, we're going to use something they call the conjugate. Hey, it's that difference of square things. Remember, if I multiply these things together, that middle radical term goes away. So, if I have a plus or minus sign in the denominator, that involves a radical. I can't just multiply by square root of 3 because I'd have to distribute, I'd have 2 square roots of 3 minus 3. It wouldn't go away, right? And I can't multiply by 2 minus square root of 3. That'd just be nastier. I'd have a whole bunch of radicals. But if I multiply by the conjugate, they're calling it in this circumstance, 2 plus square root of 3, and I have to do the same thing to the top. Then notice what happens. I'm going to multiply it out one time. 4 times 2 plus square root of 3 over 2 times 2 is 4. Okay, 2 times square root of 3 is plus 2 square roots of 3 minus 2 square roots of 3 minus square root of 9, 3 squared, right? So on the top, I still have 4 times 2 plus square root of 3. But on the bottom, this part cancels out, and I have 4 minus 3, or 1. Hey, if there's a 1 down there, I don't have to put that. So I can either distribute this if I want. I'm never going to do that to the last step, though. Because what if I'd have wound up with just a plain 4 down here? I could cancel that. And if I already multiplied it out, I'd have to factor it back out. So I'm going to wait to the last step if I multiply that. So, whoops, I said if, so I guess I felt like I wasn't, but okay. So now I can have 8 plus 4 square roots of 3. All over 1 in this case, but if it's a 1, I don't have to write that. Okay, once I see the plus or minus sign with a radical, I know what I got to do. Use the conjugate. It'll be the exact same thing, just with the opposite sign in the middle. That's all. Once I figure out what I'm doing to the denominator, do the same thing to the numerator. Okay, now I'm going to simplify this because that's 9 times 3, right? 9 times 3. Go over to the side if you need to work that out, but that winds up being 3 square roots of 3, right? Because that is the square root of 3 cubed, right? And so 2 goes into 3 one time, and 1's left in there. All right, so that's what this is. And then I have 3 plus square roots of 3. And I could keep multiplying that out with that distributive property, but from now on, I'm going to learn that shortcut if I don't already know it, because it's going to be handy. Okay, so square this one. It's always a minus, and then square this one. When you square a square root, it just gets rid of that. Okay, so now I have 3 square roots of 3 times 3 plus square root of 3 over 6. Hey, this is all multiplied in the numerator, so I can divide that out. Just make my numbers smaller before I make them bigger. All right, so I've divided that out. I'm going to go ahead and distribute now. 3 square roots of 3 plus square roots of 3 squared, or 9 if you want to write it that way, So 3 square roots of 3 plus 3 all over 2. All right, one more. Okay, 2 more. Okay, then just reducing fractions, right? Reducing fractions. So on this one, that won't reduce any. But I can factor out a what here? A 4, right? I don't see anything bigger. Factor a 4 out. From the 24, it leaves 6 minus 9. I could have factored a 12 out. So let's go back and do that. Okay. Factor a 12 out. And that leaves 2 minus 3 square roots of 7 over 16. Now, these will divide out. There's a 3 and a 4. So I can multiply that back together if I want, or I can just leave it factored. Either way. All right. Now here, this can be simplified. So don't forget, that's 2x plus, and remember what 32 is. Use your fingers if you need to. 2 times 2 is 4, 8, 16, 32. Oh, it's 2 to the 5th. There were 5 of them. All my fingers were up. Over 6x. All right, so this is 2x plus 2 goes into 5 2 times, so I can bring 2 of those out, but 1's going to be left over. And 2 goes into 2 1 time, so I can bring 1 out with nothing left over. All over 6x. So now I can write that 2 squared. I'm going to move over here so I'll get some more room. 2x plus 4x square root of 2 over 6x. And I can factor out a 2 and an x. 2x, that leaves 1. Got to have something there. 1 plus 2 square roots of 2 all over 6x. These x's will cancel, and the 2 and the 6 will cancel and leave a 3. So final answer, 1 plus 2 square roots of 2 over 3. Just using this idea of simplifying radicals to reduce fractions. Okay, see you next time.